Hi there. This interview simulation focuses on CI/CD pipelines that have caused real production failures. We'll walk through behavioral questions, technical reasoning, and scenario-based questions that test how you think when automation goes wrong. Before listening to the answers, pause the video and say your response out loud as if you were sitting in a real interview. That's the best way to train your judgment. And if you want more long-form DevOps interview simulations like this, make sure to subscribe so you don't miss the next one. Let's start with some warm-up questions. Tell me about a time a CI/CD pipeline introduced a production issue. A strong answer would sound like this. We had a pipeline that automatically deployed to production after passing tests. One day, a test suite was silently skipped because of a misconfiguration, and a bug made it into production. When traffic hit the new version, it started failing under load. We immediately rolled back, fixed the test configuration, and added guardrails so tests can't be skipped without the pipeline failing. It taught me that automation amplifies both good and bad processes. Next question. Describe a situation where you had to fix a broken pipeline under pressure. A solid response would be, a team pushed a change that broke the build stage for everyone. No one could deploy, and a different team needed a hotfix urgently. I paused the broken pipeline, created a temporary patch branch, and unblocked the hotfix while we investigated the root cause. The fix ended up being a minor version conflict in dependencies, but the key was unblocking critical work without letting pressure lead to rushed decisions. Another one. Tell me about a time you improved deployment reliability after a pipeline-related outage. A good answer might be, we realized that deployments were flaky because the pipeline relied heavily on long chains of inline scripts. They were fragile and hard to maintain. We migrated those scripts into versioned modules, added integration tests, and introduced canary deployments. Reliability improved drastically, and incident frequency dropped. Next question. How do you communicate pipeline failures to non-technical stakeholders? A strong response would be, I avoid technical explanations like, the build agent failed. Instead, I focus on impact. Deployments are paused, or releases will be delayed. Then I give a simple explanation of what we're doing to resolve it. That transparency maintains trust without overwhelming stakeholders with implementation details. One more warm-up. What's a lesson you learned early on about CI/CD that shaped how you design pipelines today? A solid answer would be, I learned that pipelines must fail loudly and early. Silent failures create false confidence, and manual checks aren't a substitute for automated validation. I design pipelines so every stage is explicit, traceable, and opinionated about safety. Let's move into technical and scenario-based questions. A deployment pipeline starts failing intermittently at the test stage, but the logs aren't showing a clear pattern. How do you start debugging? A strong answer would be, I first try to reproduce the failure consistently. Intermittent issues often point to race conditions, test flakiness, or shared resources being overwhelmed. I would isolate the failing tests, run them repeatedly, and check whether they depend on external systems. If the issue is environmental, like slow test containers or shared test data, I stabilize the environment before blaming the application code. Intermittent failures are usually a symptom of non-determinism somewhere in the pipeline. Next scenario, your pipeline deployed a broken version even though all tests passed. Where do you look first? A solid response would be, I check the test coverage and whether the tests reflect production conditions. Sometimes mocks hide real failures, or integration tests don't run in realistic environments. I also validate that the pipeline didn't skip steps or use cached artifacts incorrectly. When tests pass but production breaks, it usually means our tests are validating the wrong things, not that the pipeline malfunctioned. Another question. Your CI/CD pipeline uses caching to speed up builds, but developers are reporting that changes aren't being picked up. What's your reasoning? A strong answer would be, the cache is probably too aggressive. I check whether the cache keys are correctly tied to dependencies and source changes. If the cache doesn't invalidate when dependencies change, the pipeline can reuse stale layers. I'd also look at whether build tools are detecting changes accurately. The trade-off is between faster pipelines and correctness. If caching breaks correctness, I reduce cache scope or add better invalidation rules. Next scenario. A rollback fails because the rollback artifacts were never stored properly. The team only discovers this during an active incident. What's your thought process? A good explanation would be, this indicates a gap in artifact retention and release lifecycle design. Rollbacks shouldn't rely on fetching code or rebuilding images. Artifacts should be immutable and stored with versioned metadata. I'd identify whether the issue was in storage, naming conventions, or pipeline logic. After the incident, I'd enforce a policy that every release must have a guaranteed rollback artifact accessible through the same pipeline. Another question. Your deployment pipeline pushes to multiple environments. One environment consistently breaks while others don't. How do you reason about that? A strong response would be, I compare configurations, secrets, dependencies, and the environment-specific overrides. If only one environment breaks, the issue is rarely in the application code or the build stage. It's more likely a configuration drift, missing dependency, or a subtle difference in infrastructure. Environments should be as identical as possible. If they're not, pipelines expose those differences quickly. Next scenario. A pipeline starts taking twice as long to complete, but no one has changed anything. What's your debugging approach? A solid answer would be, I look for environmental factors, slower workers, degraded registries, network bottlenecks, or a dependency upgrade that increased build times. I also check recent merges for subtle changes that might have increased test duration or image size. Pipeline slowness is often caused by external services rather than the pipeline itself. Another question. Imagine a pipeline that triggers automatically on every merge to main. One day, 2 merges happen back to back, and the second deployment overwrites the first before the first one finishes rolling out. Production briefly enters an inconsistent state. How do you reason about this? A strong answer would be, this tells me the pipeline lacks proper concurrency controls. Deployments need serialization or queuing, so only one rollout happens at a time. When 2 merges trigger overlapping deployments, you get partial rollouts or version drift, where half the pods run one version and half another. I'd implement a deployment lock or configure the pipeline so subsequent runs cancel or wait. I'd also examine whether deployments are idempotent and whether the rollout strategy allows mixing versions. It's not just a pipeline issue. It's about preventing race conditions in the release process. Next scenario. A team added a new step to the pipeline that builds front-end assets. Suddenly, pipeline times jump by several minutes, and caching is unreliable. Where do you start? A solid response would be, I begin by validating whether the asset build is incorporating external dependencies that change frequently, which can break caching. Maybe package lock files changed, or the build directory is too large. I'd check whether the cache key includes anything too broad, causing unnecessary invalidation. If caching isn't fixable, I'd consider splitting the asset build into a separate job or using pre-built assets. The trade-off is between speed and correctness. A fast cache is useless if it's often wrong. Another scenario. You discover that the CI pipeline uses production credentials for integration tests. A developer accidentally pushes code that interacts with the live environment. What's your thought process? A strong explanation would be, this is a severe security and safety issue. Credentials should never allow tests to interact with production. The first step is to rotate the credentials immediately. Then I'd fix the pipeline architecture, separate environments, separate secrets, and enforce strict access controls. I'd also implement safeguards, so integration tests either run in isolated environments or use mocked services. The bigger question is how production credentials ended up in CI in the first place. It points to a deeper issue in secret management and pipeline design. Next question. A rollback pipeline exists, but during an outage, engineers don't trust it because it hasn't been exercised in months. They want to deploy manually. What do you consider? A strong response would be, manual deploys in panic mode tend to create more problems. If the rollback pipeline is known to work historically, I'd try to validate it quickly. Check the artifact, confirm environment variables, review logs from the last successful rollback. If trust can be restored with minimal checking, I'd encourage using the automated rollback. If the pipeline truly is untested and risky, I make the smallest possible manual change that restores stability, then immediately follow up with improving rollback reliability. The long-term fix is to include periodic rollback drills in the release process. Next scenario, your pipeline has a stage that automatically applies infrastructure changes. One day, a minor misconfiguration in a YAML file deletes part of a production resource because the tool interpreted missing fields as remove everything. How do you prevent this in the future? A solid answer would be, I'd introduce guardrails such as plan and apply workflows, where destructive changes are visible before execution. That might mean mandatory manual approval or automated checks that detect large diffs. I'd also add validation to catch missing fields, schema errors, or drift between environments. The key is realizing that infrastructure automation is powerful but unforgiving. You need visibility before changes execute. Next scenario. During a deployment, a pipeline fails at the final step, updating the service to point to the new version. The new pods are running, but the traffic switch never happens. What's your debugging process? A strong explanation would be, first, I verify whether the pipeline produced the correct manifest or configuration file. Then, I check whether the deployment tool, maybe kubectl, Helm, or an operator, actually applied the change. I'd examine RBA key permissions to see if the pipeline lacked permission to modify the service. If the pipeline logs are unclear, I manually inspect the cluster state, what version is running, what the service selector points to, and whether the rollout strategy created a blocking condition. Often the failure isn't in the code or the pods. It's in the final orchestration step that ties everything together. Final question for this section. A CI/CD pipeline is extremely reliable in staging, but frequently fails in production. Tests pass, builds succeed, and manifests validate fine, yet production deploys are inconsistent. How do you reason about that? A mature answer would be, when production behaves differently from staging, it usually means the environments aren't truly identical. Maybe the cluster autoscaler behaves differently. Maybe secrets differ. Maybe production has stricter security policies, more network constraints, or older nodes. I'd do a diff of the environments and identify configuration drift. The biggest lesson here is that a staging environment that doesn't match production is only a simulation, and your pipeline will faithfully reveal those differences. Let's move into the final section. These scenarios are deliberately ambiguous and meant to test how you think when a CI/CD pipeline is actively breaking production. And decisions have real consequences. Here's the first scenario. A production deployment starts failing halfway through, leaving the system in a partially updated state. Half the pods are running the new version, half the old version, and you're seeing inconsistent behavior. There's no clean rollback because both versions were deployed simultaneously. What do? A strong answer would sound like this. First, I stop the bleeding by freezing all deployments. Letting the pipeline continue will only deepen the inconsistency. Then I evaluate which version is safer to push to 100%. If the new version is clearly broken, I steer traffic toward the old version, even if that means manually scaling it. If the old version has known issues, I consolidate on the new version instead. The goal is to return the system to a single, predictable state as quickly as possible. Afterward, I investigate why the pipeline allowed two versions to overlap and put version locking or serialization in place. Next scenario. You discover that a pipeline step has been silently failing for weeks, but the pipeline still reports success. Production issues are now surfacing because that missing step was meant to run database migrations. How do you approach fixing this under pressure? A thoughtful answer would be, I don't rush to run migrations blindly during an outage. Incomplete migrations can make things worse. First, I identify the exact state of the database, compare it to the expected schema, and understand whether the missing migrations can be applied safely. Then I validate them in a staging environment with a production snapshot. Only after confirming the migrations won't cause data integrity issues do I apply them to production. Long term, I fix the pipeline so it cannot report success if any step fails. Silent failure is one of the most dangerous pipeline issues. Another pressure scenario. Your blue-green deployment script misrouted traffic during a rollout, causing a short but severe outage. Leadership demands an immediate explanation while you're still diagnosing. How do you communicate? A strong answer would be, I communicate honestly, but without guessing. I explain that we're seeing misrouting during the rollout, that traffic has stabilized or is stabilizing, and that we're investigating whether it was a configuration issue, timing issue, or bug in the deployment logic. I avoid definitive statements until evidence is clear. My priority is fixing the user impact, then analyzing the root cause. Leadership values clarity and calm more than instant answers. Next scenario. A developer triggers a production deployment accidentally because the pipeline lacks safeguards. Some teams argue for adding multiple manual approvals. Others want to automate more and trust tests. How do you balance safety and velocity? A mature answer would be, I look at the root cause. Accidental triggers mean the pipeline lacked contextual checks. Instead of slowing everything down with heavy manual approvals, I'd introduce automated safeguards. Environment restrictions, branch protections, required status checks, or a production deploy command that must be explicitly invoked. Manual approvals can help, but they don't scale well and often get rubber-stamped. The right balance is ensuring intentionality without sacrificing speed. Final pressure question. Your pipeline applies infrastructure changes automatically. During a high-traffic period, a seemingly harmless change triggers a full redeployment of critical infrastructure components. Latency rises, and alarms start firing. Do you roll back the infrastructure changes immediately or wait to confirm their impact? A strong answer would be, I assess whether the change is reversible without causing further instability. A full rollback of infrastructure can be riskier than letting the system settle, especially during peak traffic. If logs or metrics show the change directly caused the disruption, for example, a change in load balancer settings or node pools, I roll it back carefully. If the root cause is unclear, I stabilize the system first, scale out, shed load, or isolate components. Rolling back blindly can amplify the outage. The key is balancing urgency with caution when dealing with foundational infrastructure. Take a moment to reflect on this interview. CI/CD pipelines are powerful, but when they go wrong, they tend to go wrong fast, and often at the worst possible moment. The hardest part isn't knowing the tools, it's staying calm, asking the right questions, and making decisions that reduce risk under uncertainty. Think about which scenario challenged you the most. Was it silent failures, bad rollouts, infrastructure drift, or overlapping deployments? Let me know in the comments which one made you pause. And if you want more long-form DevOps interview simulations like this, subscribe so you don't miss the next one.